Hello, everybody, and welcome to Author Content. This is episode, what is it now? 60, 70,
No, we're like 78.
76, 75? I see someone changed my title. It says
Uh,
75, so that must be it.
yeah, I think 75 would be good.
All right. I am, as always, Morton. With me, I have my two co-hosts, James Williamson
Hello.
and Ray Vigilobos.
Are there?
And today we have special guest Kacie Hultgren with us to talk about 3D printing.
Hi there.
So,
Did you
Kacie,
just do like a Vulcan thing there for a second, Casey? Yeah.
live long and prosper. So, Kacie, can you quickly introduce yourself to the audience and tell us a bit about yourself and what you do and why you're interested in 3D printing?
Sure. So 3D printing is getting pretty hot these days. I sort of got involved in the 3D printing scene, I guess maybe 2.5 years ago, 3 years ago now. Sort of when it was still in its like DIY state, and the industry's changing a lot. I originally got into 3D printing because I work as a set designer in the theater industry, and part of my workflow is creating CAD drawings and then also creating scale models. The workflow is a lot like what you might think of an architect doing, and model making can be a really tedious task. And I got my first 3D printer to sort of help me do my job faster, and sort of fell into this crazy great movement that's going on about desktop 3D printers just becoming more accessible to the average user in their home. And so now I do some teaching about 3D printing in addition to my real job as a set designer. And some of that was producing some courses for lynda.com on 3D printing this last winter and spring.
Awesome.
Cool. Welcome.
So 3D printing, it has multiple different components to it, right? Because you have, what traditionally was thought of as 3D printing was actually more like a CNC thing where you reduce something down to something else, whereas 3D printing is building it up. Am I correct?
Right. So there's like some big umbrella terms. And the biggest one is digital fabrication, and so that word covers all sorts of processes, including 3D printing, but also CNC routing, subtractive processes like those, even computerized production of PCBs, like like motherboards and things. So digital fabrication is this big umbrella term, and then we have additive manufacturing, which is like as you said, building an object up. In the case of 3D printing, it's building it up in layers. So you might hear the word additive manufacturing, you might hear the word rapid prototyping, which when this all first started in the 80s, which was more commonly the name because it's being used by industrial designers to prototype parts.
Mm-hmm.
Or you might hear it called 3D printing, but those are all, they all refer to the same technology, and then that technology branches into dozens of other, more specific kinds of 3D printing.
Right. And
How easy it is to get into that kind of thing today? Because I know it did start out as sort of a maker kind of, movement thing.
Yep.
And, I want the Canon 3D printer thing to come out where they charge you like $1,500 for the ink and it runs out every time you try to print something. It's like, hey, replace the ink, I want it to be, but I do want it to be that easy because, printers now are pretty much given away with the computers when you buy them. How easy it is to get into?
It's getting there. And there are some companies that are exploring that model where, they're definitely discounting the machine and then selling you the proprietary cartridges that, hopefully over the life of the machine are going to pay off for them. Is it as easy as running your microwave yet? Is it easy as hitting print on a inkjet printer? Not quite. But it's getting there. So if you have any experience with power tools, or even if you have just good computer literacy, a lot of people can figure it out. But it's not magic yet.
Why do you think it's taken so long to get there? Because it seems like there's so much interest in it that somebody should, somebody like Canon or some other printing company would already kind of have some sort of package deal that would be just plug it in and you're good to go.
Well, there are some murmurings about HP getting involved, and so that could be kind of a big game changer. Sort of where the industry is at right now is like the big guys like Stratasys and 3D Systems, which have been around since the 80s when 3D printing was invented originally. And so they've been selling things for hundreds of thousands of dollars to industries for the last 20 to 30 years. And then a lot of those initial patents expired several years back, and you sort of got this like DIY maker community creating these sort of crazy machines out of, you know, basic components and laser cut parts. And so you have sort of this pushing up from the bottom, and then the big guys, deciding that, oh, actually we need to start marketing to everybody, and so then their prices are coming down, and they're kind of coming to a place where they're meeting in the middle. I don't know, maybe another year here we'll get to that point where it's really easy as pushing a button. You can buy a 3D printer these days in Staples, in Home Depot. So they're getting out there.
So what kind of price commitment do you have to make if you want to get into this?
Say that one more time, sorry.
Oh, I'm sorry. What kind of price, like how much does it cost to get into this? If you want to maybe just try it out, check it out, you don't have a ton of money, maybe you're not, like, I'm just speaking for myself here, like, maybe you're not, like, I'm not handy with tools at all. Like, you know, I love programming the computer because I don't have to, like, get any tools for it. You know, I get frustrated, like, nailing something, so I'm very leery about getting into it. But if I wanted to try it out, like, what's the easiest way for me to get into it, and how much would it cost?
The easiest way to get into it is actually not to buy a 3D printer at all, but to use one of the service bureaus that are out there. And there's one called Shapeways, there's another called Sculptio, iMaterialize, and there are tons of smaller shops. And essentially, you just take the file that you've created, and so if you have 3D modeling abilities, where you need to learn some on Linda, you can go there and figure it out. But as long as you can create that computer file, you send it away to somebody else, and they print it on their high-end systems in lots of different materials. And even as a person who has printers at home these days, I still use the commercial service bureaus because they offer me more options. And so that's a way to, you know, make one project or just try something out and see if this is really something you want to get into, if it really, like, fills a need for you. Without going out and buying a 3D printer.
Right.
Kacie, in terms of materials, what types of materials are people using with 3D printers? I know that they're even starting to get into some organic materials, but what is the gamut of materials that you can use right now currently?
So when we're talking about like a printer you could have at home on your desktop, there's two main technologies that you're going to see, and one is called fused filament fabrication or fused deposition modeling. And this is essentially a spool of plastic, like a thread of plastic, that goes through a hot nozzle, and that plastic is either going to be ABS, which is what Legos are made of, or a plastic called PLA, which is actually biodegradable, and you probably encounter in your real life in that clear iced coffee cup that you get from the barista down the street. And so those are the materials if you're using the sort of like filament-based printer. The other kind of printer you might have at home is then called SLA, and you start with a vat of liquid resin, and it's cured with a laser. And so then those resins kind of run the gamut, but I think they're kind of acrylic polymers, I believe.
Is it like a polystyrene, or what's the?
No, I think it's I'm actually not sure what it is at the. If I have one here, but it's resin that's cured. So those are really great for high detail work, but they don't do as well in schools, obviously.
And if you're working with resins, I take it you could probably colorize that resin. Is it clear initially, and then you apply different?
Most people, it's clear, it's gray, it's white. It comes in a bunch of different colors. Most people don't add color to the liquid just because it changes the chemical properties, and I think it changes how the laser cures the plastic.
Right,
so
yeah, that makes sense.
Paint afterwards. So like that's what you're going to encounter if you have one at home. If you are talking about the commercial world of 3D printing, in addition to plastics, there are also metals. Metals that are either fused together with lasers or prints that are made in wax and then go through a lost wax casting process. It's really, common in sculpture and jewelry, so it's kind of like old school meets new school.
Yeah.
And then we have this bio printing stuff that's starting to happen. These biogels that people are using a 3D printer to specifically place these gels and, make lattices that are going to grow organs and all sorts of crazy stuff. So the thing to think about is really 3D printing is a process. It's a process of accurately placing a material in layers,
Right.
and what those layers are made of, could be cement or plastic or metal. It really runs the gamut.
I've seen some really interesting. I've seen two very bizarre things that were done with 3D printing. One was something that was at the MoMA Museum, which is a big solar-powered printer that creates things out of desert sand by just focusing solar rays on sand that, after a while it melts and turns into glass, and they were actually printing some weird structure. And the other one was a printer that printed cake, so that when you got this massive cake, and then when you cut a slice through it, each slice had a picture on it. I was like,
Nice.
so you topple it over, and you could actually print your own face in the cake in a circle. So wherever you cut it, you would always get the complete profile picture.
Who wouldn't want that? That sounds amazing.
There's a
green screen and put Godzilla behind it, and then
there are commercial machines now that you can buy that print in chocolate and sugar. So if you're a high-end bakery and you want some really crazy cake toppers or cookie decorations, it's out there, and you can just buy it off the shelf now.
Nice.
Well, this is 3D printing is really cool, and it's one of those things that's like, ooh, you can do all this cool stuff with it, but then when you go look at if you go to a store where they have a MakerBot or something like that, generally they have like, here's a little toy helicopter, and here's a ball, and here's this little thing where you can twist it, and then it folds in on itself, and then it folds out again, and here's a little box. But I think beyond kits, do you have examples of things that you've made with a 3D printer that are actually practical that you can use?
I've seen a Glock.
Yeah.
A what? A clock or a Glock, did you say?
Glock. A Glock. LSPK. Those are pretty practical.
Wow. Man, I actually have something somebody made for me that's pretty cool. I had this bar camp event a couple years ago, and some guy actually made me a little robot, and he actually moves and stuff.
Seymour Morton, what the hell are you talking about? That's amazingly practical.
That is extremely practical.
Right. I mean, it is cool. It's got like a little cute motor, and he printed all the pieces out, and he assembled it together. So
he printed the motor as well?
No. The motor he bought, and he just inserted in the middle. But how much would, say that you wanted to do something like this on a service like Shapeways, how much would it cost to maybe print out, a simple thing? Not a simple, but some sort of model like this?
So, okay, I have a couple things like sitting here. So I tend to make furniture in architectural detail, so we have some commercially printed in a couple scales. So these are from the same CAD file, 2 different scales. That's
pretty sweet.
Thing is once you make it once, you can size it up, you can size it down, and then it's actually like a metal one. So something like this, to like have it printed, it's probably going to only be like $3 or $4.
Really? Wow, that's cheap.
Wow.
Yeah, but
$80 in shipping.
Actually, not too bad. But now if you're talking about like a precious metal, I think this one's like $30. And it's all about material usage. Most of these companies are charging by the amount of material that's in it. So actually your like big solid robot is actually going to be a lot more expensive than like a much more complicated like mesh structure. Most people who are like doing 3D printing for like finished products like decide to kind of like work with the technology, right? They want to do something that you can only do with 3D printing, because if you could do it with injection molding, it's going to be cheaper to just do it with injection molding. It's not meant for everything. So you can easily get something small 3D printed for under $10, but if you want to get something like larger done, those prices go up exponentially.
So say that like if I want to sit on the chair, like how much would that cost me?
Yeah,
like I want to print it like
that is really like only at this point. Those chairs that you can sit in for the most part are at museums.
Kacie, you made a great point about the cost versus what we can do currently with injection molding. So everybody that is predicting, a 3D printed revolution, which I definitely think is going to happen. When do you see, is there going to be a tipping point manufacturing-wise that 3D printing is going to become cheaper than existing methods, or is it going to be more about the functionality of a 3D printer and the just-in-time capability of it that's going to see it explode? What do you think? Where are we going to...
I don't think we're really ever replacing a lot of the technologies like injection molding that are just so prevalent and useful. But even big companies like Boeing and GM, like they are using 3D printing for like big high-end parts. Because if you only need 10 of something, and so for me, I might only need 10 of these chairs. Like I'm never going to go get something like this injection molded. It would be way too expensive. But if you're GM and you only need 10 parts, like you might be very happy to spend $100,000 on
maybe
one.
like a classic car repair shop. You know, you need one unique part that somebody doesn't make anymore.
Right.
Be probably.
And Ray, I've actually seen people doing that for older classic cars where parts they can't find them. They've had them printed. I think one day in the future, for example, if you could go to online to say IKEA and order a chair, and then you got your 3D printer in your house and it prints out all the pieces for you and you assemble them. I think that would be something that, and from a practicality standpoint, makes it feasible. The question is will we ever get there as far as cost of materials and viability of that model?
Yeah, and one of the big things now is time. Building these objects, with the 3D printer. I have a 3D printer that can print things about this big, but something that big probably is going to take 24 hours.
Wow.
Oh, okay. Wow.
Something like a chair, you need it to have a much bigger nozzle. I don't know. It's
yeah, but you think about how printers have gotten. Like, I remember I had the old image writer printer that made a lot of noise, and it would print like a page in about 10 minutes, and now you get a page spit out almost immediately. It's ridiculous how fast they are. So I think with time, maybe that kind of stuff will normalize.
Yeah, they need some more technologies. I think some of the technologies, the FDM in particular, like it's not going to get any faster. Like it's kind of where it's at. What we need to happen is some of the faster technologies that are currently under copyright need to.
I'm thinking like genetically modified bees would be really cool, and they go and just put it all together, right?
Yeah, that'd be perfect.
Sure, Ray. You should get on that. You should go ahead and patent it. You should go to Apple.
Robotic.
Apple, just go ahead and patent it now, and then work on actually doing it.
Nanobots.
Yeah.
I've watched 3D printers work, and what I noticed was part of the reason why it takes so long is, of course, that you lay down a layer, but then you have to wait for that layer to dry completely before you can lay down the other one. And then if you make it go too fast, you get these, that starts melting. It ends up looking like some sort of bizarre, horrible, degenerated thing. There are inherent challenges in this stuff that go beyond printing on paper, like the fact that you're actually printing with real physical materials that come in one form and then have to be changed into another form before it can be used.
Right.
So I'm wondering, I was at the dentist, and how they have some sort of thing and they go into your teeth and then they put a little light on it to cure it. And I was thinking, maybe there will be a printer that prints out something that has a little UV light that cures it immediately, so that it can go much faster instead of having to wait just for it to stop.
Well, they're using lasers now, right, Kacie? They're using lasers.
It's not that much different than the SLA or the DLP ones are actually it's like a projector. It's like projected light that's carrying the resin. So that tool in your dentist's office is a non-automated printer.
Yeah, there's a dentist that's the actual printer.
Yeah.
So how far away are we from the Star Trek replicator? T.
She already has one.
Yeah.
Not allowed to show us.
It's it's I think we're a ways away from that. I think our first step is getting to the point where we're combining like soft rubber materials with a hard plastic material. You realize like a lot of the objects you use in your life, like they have texture to them, right? Like they're made of multiple things. And a lot of the printers, especially the ones that you're going to find in homes, are only printing in one material at a time, or maybe two. But we need to get more sophisticated to a level where people would like take an object off that 3D printer and be like, yeah, I'm going to wear this as a necklace, or I'm going to use this object in my everyday life and not feel self-conscious about the fact that it's 3D printed.
If you made that chair tiny enough, like you could wear it as an earring, I would, I'm still doing that. I would totally go for it.
Yep.
Metal, come on.
I've seen some very interesting things that are being done with 3D printing that go beyond, trinkets and doodads. Like, you have all the practical things, like replacing a part with something else that you can make yourself. But you also have these new things, like a custom cast for someone who broke their arm.
Yep.
And all this medical 3D printing stuff that isn't just printing tissues inside your body, but also printing things that are extremely hard to make and are highly customized to each individual and all that kind of stuff.
Yeah, the prosthetics are big right now. There are lots of folks, creating these sort of ingenious but very simple prosthetics for kids who are born with birth defects where they don't have fingers or they don't have palms. The original guy who invented it was a woodworker who lost some fingers in a woodworking accident and was really disappointed that there weren't any functional prototypes that would help him return to work on the market. And with a 3D printer, he designed one that fit his need, and then realized there were all these other people that could benefit. And that's one of the really interesting things about people having these machines at home, is that you can have collaboration on a project across countries and oceans, where people are sharing these digital files, and I have a copy where I'm at, and you can print a copy where you're at, and we can experiment and share and build on that in a much more interesting way. And the plastics aren't expensive, so you can churn out 50 hands and send them to Africa.
Is there a fairly large online community that is doing these types of things, where they're sharing files and being open about it? Are these things up on GitHub? I'm curious.
There are. There are communities like this one I'm talking about in particular. There's a few names. One of them is Enable, where they're really working together on sort of single focus. And then there are tons of 3D file repositories where people are sharing the work that they do with the world. A big one is Thingiverse. That was kind of like the original one. And there are lots of others. Imagine. Lots of people trying to get into the game and figure out how you find an iTunes model that works for 3D printing files, and that's not really there yet either. I think that could be a real game changer, but nobody's quite figured out how to transfer these files without leaving the files open to pirating. If you're going to get designers to really invest their time, they need to have some sort of IP protection. So most of the sharing that's happening out there is very free and open at this point.
Something you said earlier kind of struck a chord with me, because one of my first jobs out of college was working for a pre-press service bureau, where we would create separations and films and RC paper and chrome-lens and color keys for graphic designers and advertising firms that would then take that to a printer. And it seems weird now to talk about that, but that was that's what we did. We printed out film. Do you ever foresee a time where you might go down to your corner CVS where they have a large-scale industrial 3D printer the same way they have those photo machines, or do you see businesses opening up that are going to specialize in this? And I know there must be some now because you were talking about the commercial ones, but do you see this becoming a much bigger thing than perhaps maybe somebody having it inside their home?
Yeah, it's starting to happen already. I know Staples in Europe for some reason has started experimenting with having this printer called the M-Core in their stores, which is actually cutting layers of paper and laminating them together, which is kind of an interesting way to create like a presentational model. And so that is definitely starting to happen. I don't know if it's going to go the way that, you know, it just gets cheaper. Definitely schools and libraries. Libraries are starting going big into 3D printing as being like an interesting place that you can, like, you know, in your community go to get some hands-on time with one. And there are some corner shops that are opening up. Most of them, you know, they're selling 3D printers, they're teaching classes, and sometimes they'll have like a high-end machine to use. But I think it's still, because the market's still growing, and a lot of people don't, if they do know what it is, they don't know why they would want to use it yet. And
Right.
So it's hard to find a big enough audience for those stores, even in large cities, but they may get there. I do think that in a culture where we're kind of used to Amazon.com and ordering things online, you know, keeping these businesses online might be more profitable than the brick and mortar sort of neighborhood store option, but you never know.
I'm thinking that this could, like, you know, when we talk about things, we generally think in our own kind of sphere, the North American sphere or the Western European one, where, you know, everyone has access to everything at all times. But
Right.
3D printing is one of those things that, to me, seems like it could be a tremendous benefit to people who are in more remote locations, or locations where, you know, you can't just order something off Amazon. That would cost an enormous amount of money and take forever. And also in places where, you know, like, let's say you're on an expedition somewhere, and all of a sudden you have something you need, and it's like you just can't get it. But then you have a 3D printer with you that you can just run out whatever it is you need. You just bring the raw material and then stuff it in, and then download whatever file you need and get it fixed. The one thing that I'm really curious about with anytime this type of technology comes out is what you were touching on previously, this idea of who owns the rights to this stuff, right? The idea itself, because if you remember several years back, when you bought a DVD, there would always be this ad at the very beginning of the DVD from the FBI or something like that was like a kid that was stealing a car, and then it would say, you wouldn't download a car, so why would you download a movie? And now there's tons of these graphics on the web where it's like, it says, you wouldn't download a car? Of course I would. Well, it says it in slightly rougher words, but I can imagine all these manufacturers, like specifically Lego, which is, you know, something that would be very easy to reproduce. You wouldn't even have to have CAD drawings. You could just sit there and measure it or scan it in. And all these other manufacturers that have proprietary rights to designs, they probably would start getting really concerned about losing market share to someone being able to do this at home or just downloading a file and doing it.
Yeah. There's actually something interesting happening with Hasbro and Shapeways specifically. These service bureaus like Shapeways are also marketplaces where people, you know, sell their designs to others, and it's really just like putting up a posting and somebody orders it, the company makes it for them and ships it off and pays the designer a royalty. They have a huge problem with like the movie prop community and people who are, you know, designing. There's a lot of instances of them getting takedown notices for things that companies feel infringe on their rights. And so recently, Hasbro, with the My Little Pony brand, which there are lots of sort of My Little Pony fans.
It's the bronies.
The bronies. There are lots of bronies available for purchase on Shapeways that have been there a while. And recently, Hasbro actually sort of gave their blessing. And said, we feel like this adds to our brand, and I guess they've figured out some sort of, like, they have some sort of special Hasbro My Little Pony Brony store on Shapeways now, and the artists are, I guess Hasbro is giving kind of some approval, some artistic approval to sort of, you know, prevent obscenity and things like that. But they are blessing it instead of sending a takedown notice. So that's sort of a, you know, what happens when other companies do that, and is there a way for these companies to actually work with independent designers to make more custom things available? Because there's a lot of things in the world where you do only need 10 of them, or maybe 100 and not 1,000, and it's just a very different paradigm when independent designers can design and get paid for work that might not have a broad audience, but it's going to be very popular.
I definitely think that this is going to be, in the long run, extremely disruptive.
Yeah.
Because you can't enforce those rights. Anybody that is able to make a Lego is going to make a Lego. There's not much you can do about that. So
I think right now that the fact that it's so kind of time-consuming would prevent people from going into mass production. But yeah, they're like, James is saying, you're absolutely right. There's no reason why somebody can't just copy a My Little Pony that they like and print it out and take it to like a Comic-Con and sell it. I mean, people sell drawings at Comic-Cons of characters that they really don't have licenses for, and that's actually really cool to see that some people allow that. So that's a really cool move from Hasbro.
I think it's really interesting. It'll be interesting to see if some more brands catch on.
And it's interesting from another perspective too, and that is, the 3D printing explosion has grown out of this maker movement and this open source mentality. And it's kind of funny when you think about where these original ideas of the open source movement came from. It was a guy who was frustrated that he couldn't fix his, I think it was a Xerox machine or printer or something like that. There was one particular part. There's this little tiny dumb part that was missing that he was able to find anywhere, because it was like a spring or something. They could just buy any random spring and make it work. But then when he put that into the machine, the company that had made the printer said that he had voided his warranty because he didn't have the rights to change this piece, right? Even though the piece made no difference. It was just like a spring or a little piece of plastic. And from there grew that idea of these non-proprietary things where there's an open standard for certain parts. People can do it themselves. And I remember reading the original document and thinking, this is a description of 3D printing. It's just a description of 3D printing way before anyone even thought that would be possible in your house. And I'm seeing, the open source community really embrace this. For instance, like the original MakerBots, correct me if I'm wrong here, but I think if you have one, you can make it print another one, and you just have to buy some key components and then get it.
Yeah, not as much with MakerBots. The MakerBots sprung out of this project called RepRap, and the RepRap project was all about creating self-replicating machines, and they sort of went with 3D printing as a technology of doing it. And so the idea is that you can just buy some bearings and linear rods and stepper motors, and you just create all these connecting bits. It's very interesting to see like the original, like one printer that fathered a second printer, and now there are like thousands of them.
I gotta be honest. I've watched so much science fiction, self-replicating machines. Like, I get real nervous about that concept.
Well, self-replicating
printers.
I don't know.
But this idea that you can create a machine that can create copies of itself and then also be useful to you in the meantime, doing your bidding, creating whatever it is that you need, whether that's little tiny chairs or parts to fix your microwave or whatever.
I was actually the other day cursing that I didn't have a 3D printer nearby, because I have this bicycle cell phone clip. And my bike, the rod that holds the handlebar is not circular. It's kind of it has a circle on top, and then it's long, and then it has another circle. So the clip that came with it isn't big enough, and I couldn't make it work. And I'm like, if only I had a 3D printer, this would be like, I'd set it to go overnight. I could make it exactly what I wanted and just solve the whole problem. And then I was thinking of calling my friend John, who has a 3D printer, and I'm like, nah, he'd have to come here and measure it and everything. But and then I was thinking about, wait, do I actually know how to do this? No.
We do. We have such a disposable culture on right now. I'm kind of curious to see if in the future people are more willing to try to fix something than throw it away. If that ability to print something out and plug it in really quickly exists. I'm kind of interesting to see if that actually does anything for us.
Well, in some ways, like the 3D printers are like the garage shop that people don't have anymore. You know,
Yeah.
like my grandfather had a whole shop in his basement and in his garage, and that's just not as common. You know, that used to be really universal. Like, people knew how to make furniture. They knew how to create things, and you know, in the last like 50 years or so, especially, that sort of has gone downhill. It's not popular. It's not something people pay attention to. And in some ways, 3D printing is a tool for the urban person. You know, I live in a small New York studio apartment, and I have, well, right now, 3 3D printers in my apartment. But there are not a lot of power tools that I can get away with using in my home. But 3D printers are one of them. And so I think in some ways it's just connecting you know, a generation of folks who are very digitally inclined to this idea of creating something, this idea of manufacturing something. Suddenly you realize that all these things you can do in a computer, it's just like a couple more steps to get something actually like manufactured in China. So it's a connecting mechanism, and I think when people like really think about that, that's what starts to be part of that paradigm shift.
So let's talk a bit about this whole idea of making something yourself, because it's not just click the. Well, you could download a file and then upload it to the printer and get it to print, right? But there's also the I want to make something myself. So what do you need to know, and what kind of tools do you need to be able to do the design component of this?
So the great thing is that there are tons of CAD packages out there, sort of computer-aided design that let you create a 3D model. And most of these programs have sort of roots in the like architectural drafting, in mechanical design, in character design for film and video games. And so all of these programs can create 3D files that are ready for 3D printing. So you sort of just need to find one that you want to spend some time with that's going to meet your needs. There are a lot. They all appeal to different styles of working. They have pros and cons. You need to have develop some sort of prowess with a 3D modeling tool. If you're just getting started, there's some really great free ones online. Tinkercad is one specifically that was developed by a startup and then purchased by Autodesk several years ago. And it is free, and it's really intuitive. If you can build something in Minecraft, you can probably find something.
You said the magic word. I can do this. I can do this. I'm so excited now.
No,
I
actually,
gotta check that out.
Export your designs out of Minecraft and
dear God.
Tinkercad, and then just like edit them a little bit more. I didn't know that was kind of such like a powerful impact.
That was awesome.
Look at what's behind him.
9 and 10-year-olds that I talk to on occasion just throw up Minecraft and the room explode.
Yes! I can pray my own axe.
It's like you just said the magic word on Sesame Street or something. You know?
Exactly. And so, you know, if you get started there, you can sort of get acquainted with the concepts, like, you know, breaking down a three-dimensional shape into sort of the basics, like you would if you were learning to draw, right? It's like, you know, this mouse I have here, oops. You know, it's kind of like got a circle here on top, it's flat on the bottom. You could, you know, you can, as long as you think about how a shape is made, like, you just have to start practicing that skill of thinking in 3 dimensions. And once you learn one program, the second one you're going to learn is easier. Just go from there.
Is that how you got started with this? I mean, how did you get going? Did you have a background in this at all?
I had a CAD drafting background when I got the 3D printer, and sort of when I got started, it was still very, you know, I built my first one from a kit, and I had enough sort of hardware knowledge to learn that I was happy that I already had the software background. So I'm primarily an AutoCAD draftsman, and I just, you know, sort of started working on my 3D skills in AutoCAD, sort of, you know, figuring out how to do more and do better. You know, at this point, I actually need to learn like a mesh style 3D modeling program like Maya or 3ds Max or Blender to sort of like augment the skill set that I already have. But yeah, so I came to 3D printing with a CAD background, and that certainly helps. But there's a lot of tools out there now that really let anybody get started that, you know, weren't there 5 or 10 years ago.
Has Google gotten started with anything yet? Have they made any software
Well,
for it?
SketchUp, which doesn't really belong to Google anymore, but used to for a while, and SketchUp kind of came to fruition before this 3D printing sort of desktop revolution, and you can use SketchUp to create designs for 3D printing, but just the style of the program, you need to be a little bit more careful. SketchUp and also a lot of the mesh editors like Blender, 3ds Max. They're more
actually SketchUp. I'm sorry, SketchUp. Me being like all thumbs when it comes to 3D, SketchUp is really easy to use. I really would appreciate something that has that kind of beginners kind of less of a barrier to entry.
The only thing about SketchUp is that it's based on like drawing faces, right? You sort of make faces rather than assemble shapes. Right. And so when you're making those faces, you need to make a design that's closed. Like you need to make sure that when you're finished, all of those faces meet up on the edges, and that there's something it's called being watertight. And the program itself, it gives you some tools to help you do that, but you have to be thinking about it while you're doing it. And so you can end up with objects that look good on your screen but aren't really ready for 3D printing. Where something like Tinkercad was made for 3D printing, essentially, and it's going to create a 3D printing ready object by.
No, you sold me on Tinkercad. You don't have to go any further.
Okay.
Photoshop has some sort of 3D printing features.
Yeah, they do. They're getting in the game too. Everybody's getting in the game, and the Photoshop tools are really great if you already have a graphic design background and you're used to making logos or art already. The easiest thing is to just take a 2D shape and essentially extrude it into 3 dimensions. So it's great for like text, drawings that you might have made in like Sharpie, and then you can export those and either directly 3D print them or take them into a program like Tinkercad and do a little bit more work on them.
It's fashionable sometimes to kind of bash Adobe, but from what I've heard, the printing capabilities out of Photoshop is really, really good. I've heard that they've done a nice job with it.
Yeah, it's not a fully featured CAD program, so you're not going to be able to do everything, but the things it does allow you to do are really simple and straightforward. I actually did some, I got married this last spring, and so I made some 3D printed like table number things. It was like a Photoshop Tinkercad project, sort of just.
That's kind of cool.
Just really easy way to like take text and turn it into a 3-dimensional object.
So crazy. So how much, if I wanted to get myself a 3D printer after convincing my wife that this is something that must happen because we need it for some reason, what am I currently looking at in terms of cost? Or should I be waiting for some new technology to come out?
No, I mean, I think now is as good a time as any. There's a couple, they kind of range. So you can get, especially if you back something on Kickstarter, which is not necessarily the right way to go, but you can get something for a couple $100s.
In 2016.
In 2016.
For $48.72.
And there are some small printers in that $300 range. If you're a small business user or a freelancer or somebody who obviously those buying decisions are going to be a little bit different than a hobbyist who just wants something fun to play with on the weekends. Mm-hmm. I usually am more comfortable with the machines that are in the $1,500 to $3,000 range because they do work for me.
Right.
And I want them, the time that I put into working with them to be productive and cost effective. So that's kind of the range. I actually, in a couple weeks, am going to be participating in a review weekend for Make Magazine. They do a sort of a yearly issue, a buyer's guide on 3D printers. So I am super psyched to have my hands on 20 different 3D printers in a couple of weeks here to sort of see what's new and interesting and sort of how the market's changing.
And the materials themselves. I know you talked about this. I have a friend who does a lot of 3D printing and keeps printing this stuff. He says it's soy-based or something that technically you could, bury in the garden and eventually just go away.
PLA.
Yeah. What's the material cost involved in
Not very much. Here, hold on.
We'll have some pause music while Casey's.
Dun, 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 dun.
Like, this is a roll of plastic. This is
Whoa.
Whoa.
Looks like fishing line.
Yeah, it's like
Or wire.
2 meters thick. This is actually ABS, I think, but both ABS and PLA for a kilogram, you're going to spend about $30 to $50, and
$30 a kilo? That's pretty cheap compared to other things.
Yeah.
We're not sure what you're thinking out there.
It's not bad.
And that's like where the desktop 3D printing really excels, is that once you've made that upfront investment, the consumables are open market. And so you can get your generic 3D printing filament for $30, $35, and these days you can even buy them places like Micro Center. Like, you can actually go to stores and buy them now, which is very interesting. In that, I have a lot of these at home, but they last quite a bit. You can get a lot of 3D prints out because for the most part when you're 3D printing an object, it's not printing solid. It's printing with like a honeycomb sort of structure in the middle. And so the amount of plastic you use is just really, can sometimes be fairly inconsequential.
Ray, what are you building?
I'm building a bot, of course. This is like a robot.
It's a robot.
It's going to be awesome.
Wow.
So I'm really into science fiction, and I read a lot of science fiction books. And I found this book recently. It's called The Great.
I bet you're shocked, aren't you, Casey?
Yeah.
Shocked. Yeah.
Sorry, what was the name of the book?
So there's a book called it's called Great North Road by Peter F. Hamilton, and it's a typical science fiction space opera type thing with aliens and crazy things. But the plot line in that book is really interesting because the idea is that there are a bunch of people that are going on an expedition to find out what's going on, and they bring with them what's referred to as raw, which is just raw materials, and they have like 3 types of raw. There's like a metal raw, plastic raw, and an organic raw. And then whenever they need something, they're like, oh, we need a backhoe. We'll just build one. And then they print out a backhoe. And then when they're done with it, they're like, well, we need something else. Then they can render the backhoe down to raw material again and then reprint something else. But then, of course, there are issues with it because the material deteriorates over time, and you have to bring more, so there's a limit, so you have to kind of budget for the next 6 months, how much are we going to print, and are we being frugal with our materials? And I actually found that part of the book extremely compelling, this thinking about what's this going to look like a distance into the future, when we could technically say, I want to buy a new car, and then just get it printed. Or when, if you're on an expedition, you can like get a printer to build a house for you or something like that.
Well, they're talking about this for like space travel, right?
Yeah.
To like go to the moon, and you don't have a lot of room to carry big bulky things with you, so you just pack up your raw in the spaceship, and you unpack your 3D printer and get to work making whatever it is that you need up there on the moon. But that's like happening. Like, people are talking about that and researching it and figuring out how to make it happen.
Build it out of regolith. Just truck made out of stone because it's on the moon, so there's less gravity. It's I just find it extremely compelling to think about where we're heading with this. Do you think that everyone will have one of these in their house? Will this be a thing? Or maybe not in their house, but let's say every neighborhood will have like a communal 3D printer that you can just go to and get things printed out.
Maybe eventually. I've actually heard people talk about it more like an espresso machine, right? That like not everybody has one, but the people who do have them love them, right? Like, it's not going to be in every house, but it might be in every 50th house or every 25th house, and maybe we will get to a point where they are totally widespread. But I think that first step is really getting them into more houses, but in places where people are going to be like really interested and excited to have them. A 3D printer really only makes sense if you need and want something specific. right now. That sort of general audience, I think we're a little ways away. But we're going to see that sort of first step of sort of espresso machine dispersal, I think, before we see everybody having one.
Interesting. We need to have this conversation again in 12 months.
Right.
And see if
what's different.
All of us. Once my robot is available for sale.
Yeah. Ray will have this mad-sized robot behind him.
Yeah.
That he printed from, and James will have a house full of Minecraft cubes.
A bunch of Glocks.
His daughter has.
I'll just have a room full of Glocks.
It'll be like Rambo, you know.
Extremely practical.
All right. Well, we are out of time for today. If you are watching this show, or if you're listening to it, or anything like that, I've been using the new Showcase app throughout this episode. So if you go and look at the Google Plus page for this event and watch it on Google Plus, you'll see the links to all the things that Casey's been talking about right on the side, so you can actually get directly to them. So you don't have to go scurry through the show notes anymore, because Google apparently is innovating again. And,
that's nice.
This one actually looks really nice, so I'm quite excited about that.
Cool.
Like I said, that's full time for author content. I would very much like to thank Kacie for
thank you.
And expanding our understanding of 3D printing. And,
yes, you can tell we're sort of totally ignorant about this. It was all pretty much questions like, how does this do anything?
So if people watch this, want to get more involved, where can they find you, or more information, or can they talk to you about what?
Yeah, definitely. Twitter's the best place to reach out. I'm at Kacie Hultgren on Twitter, and just send a tweet, ask a question.
Or go check out the Lynda course, which we have linked to in the Showcase app. I'd also like to thank my two co-hosts, James Williamson, who will be building Minecraft stuff.
No.
Ray Vigilobos, who's
however his daughter is going to make this great house.
My daughters will be building a bunch of Minecraft stuff.
And yeah, that's it. If you like author content, you should go check out our website. It's at authorcontent.com, where we put show notes and links to the videos and everything else. And we will be expanding it with more information about the guests and whatever when we have time. Ray's like, no, we're not, because Ray's the one that does all.
You're welcome to. Yeah.
I will theoretically be doing it. You can also get us on YouTube or on Google Plus
and iTunes.
And iTunes. So if you just want to follow along without actually seeing what we're talking about, iTunes is the place to be. That is full time. We're back here again next week. Maybe we're not back next week. I think I'm on a plane during the show next week. We'll figure that out. We might be back next week. If I'm not, maybe Ray will drive the bus again or something. In the meantime, watch the show again, watch all the backlogs, and have a great day. We're back here again. Same bad time, same bad channel.
Bye.
Bye.
Bye.